Hi, algebra class. Mr. Lang here. Just wanted to do a very quick lesson on 3-2 and 3-3 so that you guys can work through some different pieces. Since I'm not here, unfortunately, we're going to skip some of the fun stuff and just get right to the lesson. We are going to use our classic solving skills to pretend in secret like this is an equal sign. We know it's not an equal sign, but we're going to solve like it's an equal sign. So we would do everything the same. I'm going to use my green to add the 3 to both sides. So I would get my answer D equals -3 here. However, we can backtrack and know that that is not an equal sign, right? So if we work our way back, actually it's a greater than or equal to sign. So when we think about D as anything greater than or equal to -3, we got to think on our number line. If this was -3, when we have negatives, I want you to kind of locate 0. So -4 would be to the left. -2 is actually bigger to the right. So then we would do an equal to filled in circle. D is greater than -2, which would be to the right. And we'd have you draw it like that. Okay, so 3-2 is some pretty standard, basic, one-step algebra problems doing to both sides. But they'll throw some things to mess with you, like some decimals. Right away, I noticed that this one has 2 decimal points where this one does not. So I'm going to go ahead and make that also have 2 digits. So if we think about it instead as 0.70 is greater than, that will help me when I go to solve this. Subtract 0.15 or 15/100ths from both sides, and I would get 0.55 is greater than x. Well, we have to remember if 0.55 is greater than x, sometimes it might help to think about money. If I say 55 cents is greater than x, that means x is actually lower than 55 cents, right? So when I think about my graph, I'm going to go 55 cents here. Well, what's more than that would be 56 cents. What's smaller than that would be 54 cents. So when I go to graph that, it says 55 cents is bigger than x, so x is not equal to 55 cents. It's actually lower, so that would be to the left. All right, there will be some quick word problems. Here's an example, right? Bulldog power. Let's say your max bench is 220 pounds. Woohoo! But you have a goal of 250, so you're not there yet. Okay, so here's the situation, right? You have now and you have your future. Your future, you want 250, but are you okay with having more than 250? Definitely. Okay, so that's your goal. So instead of future, let's call that your goal. Okay, but we're okay with us being more than our goal. So we want to be greater than or equal to the goal. So we can already bench 220 plus some more weight, and that would be greater than or equal to 250 pounds. So at least how many more pounds do I have to go? Well, you guys probably could do the math in your head, but if I just subtract 220, the weight has to be greater than or equal to 30 pounds. So 30 pounds for the tie, or I can go beyond my goal by doing over 30 pounds. So again, just really quick, some standard ones. We just put the line down the sign here, and then we add 11 to both sides. Add 11. We say x is greater than or equal to -8. Or in the future, we could have multiplication. So 2 times what is smaller than 31? Well, divide by 2. If I'm going to divide a number by 2 and it's an odd number, I'm probably going to end up with a half. So that would be x is less than 15.5. All right. And then I got a spot to graph them down here. So x is greater than or equal to negative 8 would be greater, would be to the right. Yes, negative 7 is bigger. And then x is less than, so not equal to 15.5. So you could do super general like that, or you could get advanced and do something like this, do 15.5. Well, 15.6 would be bigger and 15.4 would be smaller, and that would just be a little bit more accurate. Okay. Or you could get even more accurate and say, all right, this is 15.50, this is 15.51, this is 15.49, and you could just keep going more accurate and more accurate and more precise. But any of those three would be acceptable. Okay. Then we move on to 3.3. I got this crazy true and false table, so follow along with me. 14 is greater than 8. True. 28 is greater than 16. True. All I did was double it times 2. Okay, but then look what happens here when I multiply by a negative 2. The same sentence, all I did was double it, but it became false because I did it times negative 2. But then if I do half the size, 14 and 8 cut in half would be 7 and 4, it still stays true. But if I were to do a negative half of 14 and 8 would be these negatives, which would be false. So basically, want to just kind of draw your attention here. When we did the negatives, they became false, even though when we did positives, the original, they were true, true, true. I wonder if there's a pattern there. What do you notice? Well, here is the moral of the story, star, blah, blah, blah. Whenever you personally, whenever you multiply or divide, notice it doesn't say addition or subtraction. When you multiply or divide an inequality, both sides by a negative. When you multiply both sides by a negative, you have to flip that symbol. All right, so taking a look here, two different examples. The one on the left, the negative 2 is on the left side of this, right, attached to the x, where on this one, the negative sign is on the 16, and that's on the right. It's not really the left or the right, but it's just what you would do. How would you get x? You would have to divide by negative 2. How would you get x? You would have to divide by positive 2. This line is you, your work. This line is you. Did you divide or multiply by a negative? Yes. So you divided by negative 2 here. So that means your symbol has to come here and change direction to stay true. So it would be x is greater than negative 8. Okay, so I divided by a negative, I have to flip that symbol. But what's different over here? What are you doing? You divided by 2. Divided by 2. That is a positive 2 that you divided by, so you don't flip. You just did. Who cares about the negative 16? Yes, that is negative right here. That is negative 16, but this is what you did. You divided by 2, you divided by 2. That's you on both sides. It's a positive 2 that you divided by, so you don't flip that. So although it would give the same answer, the symbol would go the other direction because it would stay the same right here. Stay the exact same because you did not divide by a negative. You divided by a positive. All right, so try some of the homework, and then when you're done, log in and make sure that you check your answers in Schoology. The answers will be in the Chapter 3 folder titled 3.2, 3.3. Thanks a lot. Hopefully it goes well for you. We'll check in and clean up the pieces on Friday. See you Friday for some good news. Bye.